Has anyone ever gotten their package stolen? Sadly, this is a rising issue due to the pandemic. More and more people today are purchasing things online and having it shipped to their homes. Currently, delivery personnel do not require a signature and they just drop the package at the front door. This provides an opportunity for porch pirates to steal them. The problem can be solved with a simple solution. The answer is PorchGuard. It is the next step to keep packages safe. It is a project first proposed by our client Stephen Knudsen and was developed by Abuni, Brighton, Kelly, and Yogini. PorchGuard is a monitoring system that uses sensors to watch for your packages and alerts you if it has been compromised. The system is connected via Wi-Fi and can be set up using the app, and is designed to monitor your package and provide you notifications about the status of it. The PorchGuard system will monitor a package once it is placed on top of it, and sends you notifications that your package has arrived. If someone attempts to steal the package, the system has an alarm system to deter porch pirates, similar to a car alarm. If the alarm was accidentally triggered, no worries. You can use the app to rearm it or disarm it to grab your package.
Our system basically has two parts. We have the hardware and the mobile app. So how our system works is that it alternates between three states: the idle state, which is when the package has not been delivered and the system is just waiting for a package; the monitoring state, which is when a package has been delivered and the system is currently monitoring it; and the alert or alarm state, which is when someone tries to take the package or tamper with the system and the alert is being triggered. So our system starts off from state 0, which is the idle state. And once the package is delivered, it moves to state 1, which is the monitoring state. It also sends a notification to the mobile application to let the user know that the package has been delivered. If the package is moved, the system moves from state 1 to state 2, which is the alert state. It also sends a notification to the user to tell them that the alarm has been triggered. Now the user can click on this notification, which takes them to the mobile application. And from the mobile application, they can turn off the alarm, which takes it back to state 0. And now the alarm has been turned off. Now the user can choose to continue monitoring by clicking on the continue monitoring button, which takes it back to state 1. Back in state 1, if the load cell is moved, the alarm is triggered again. Also, if the platform is moved, the alarm is also triggered. The user can choose to reset the system by clicking the reset button, which takes it back to state 0. Now in state 0, when the load cell is moved, the alarm cannot be triggered.
On the hardware end of our project, the firmware for our prototype has three states: idle, monitor, and alert. In the idle state, it will wait for the package to be placed on top of the weighing scale. In the monitoring state, the system will monitor a package using the sensors built in the package placed on top of it. In the alert state, the system will trigger an alarm if the system itself or package has been tampered with. The way the Arduino communicates the states to the app is through the real-time database as shown here. State 0 means that it's in idle state currently, and right here is the serial monitor that the Arduino prints for data values. Now, when I place a cup on the weighing scale here, the state will now change to 1, as well as the Arduino will say it, as well as now the Arduino will record initial values for it to compare if anything has been changed. Now going back here, if I remove the cup, the Arduino starts beeping and flashing, and as shown here, it is now in state 2, and the Arduino serial monitor prints out the alarm. Now, if I just edit this in the real-time database and change it to 0, the Arduino will stop beeping. The XYZ values in the serial monitor is the accelerometer on the Arduino. It's just for preventative of case if someone tries to steal the actual system itself, as currently it's in state 0. So when I lift this, it will now change to state 2 and start beeping. The ultrasonic sensor also works as we are in state 1. It reports initial distance value, and say if someone tries to either shift or move the package, it will now change into state 2 and start beeping.
So our mobile application has three major functions. We need to be able to turn off the alarm, set the alarm to monitoring state, or reset the system. And right now the alarm is turned on, and it's in state 2. So once I click on this turn off alarm button, it goes back to state 0, which is the idle state. But if I want to continue monitoring the system, maybe there's still another package and I still want to keep monitoring, I could click on continue monitoring, and it takes us back to state 1, which is the monitoring state. And if I want to reset the system back to idle, I just click on reset system and it takes it back to state 0, which has reset the system. Another key functionality of our system is being able to send notifications. And just to remind you, state 0 is our idle state when nothing is happening. The system is just waiting for a package to be delivered. State 1 is the monitoring state when a package has been delivered. And state 2 is the alarm state when the alarm has been triggered, for example, when someone tries to steal the package. So I'll show you how the notifications are being sent on change of the states in the real-time database. So right now we're in state 2, and if I change this to state 0, the alarm has been triggered and I'm resetting the system to state 0 and get a notification. So it says your system has been reset to idle state. We can clear this. And from state 0, if I try to change it to state 1, another notification, your package has been delivered and is being monitored. So you can clear this. And let's say someone tries to steal the package and the system sends it to state 2. So another notification, theft alert, your alarm has been triggered. So when you get a theft alert, you probably want to check what's going on, and imagine the person checks and there's actually no thief. So we click there and turn off alarm, so it sends it back to state 0.
What worked and what didn't work? Our system's main parts work. It recognizes when the package is placed and sends a notification. It continues to monitor the package and the system and keeps it from being stolen. And if the package or the system have been disturbed, then the alarm gets triggered. Things that didn't work are we couldn't use the proximity sensor because we only had one I2C port, and also we had planned to show history of the packages delivered, but due to the time crunch, we put it as a stretch goal.
Allow us to go over some future improvements that could benefit the PorchGuard. Right now, the system relies 100% on line power, but what if a Porch pirate were to just find a way to cut the power or unplug the device? It would sabotage the entire system. Therefore, it would be beneficial to have an inconspicuous battery-powered backup hidden somewhere on the system or underneath it. That way, if the system was somehow unplugged, it would continue to run and keep your package safe. The second improvement would be to use a better microcontroller rather than an Arduino. The system would be equipped with multiple I2C ports, allowing us to use both the ultrasonic distance sensor and the proximity sensor simultaneously. For our prototype, we abandoned the proximity sensor in favor of the simpler ultrasonic sensor. but the retail model of PorchGuard would be better served with a backup sensor for hardware fault tolerance purposes. Not only that, but industry standard microcontrollers are actually cheaper than Arduinos, and that would offset the higher costs of the embedded device upgrades made for the retail model. The third improvement would be to use a more powerful LED and piezo buzzer alarm system. For the prototype, cost-effective components were used, but a more robust and loud alarm system would be paramount for deterring Porch pirates if PorchGuard were to be professionally sold on the market. The fourth improvement is to use a large and stable platter that would be fabricated for the packages to be placed upon for monitoring. Underneath the platter, the load cell would be hidden as shown in the demo, but the other components would be protected as well. The only visible devices should be the distance and proximity sensors as well as the LEDs for the alarm. Some improvements could be made to expand the mobile application as well. For the retail version, it would be made compatible for Apple devices as well as Android. The current prototype has only Android compatibility for now. The application would also have the ability to log past deliveries, with appropriate information regarding their delivery times and statuses. And lastly, the application would enable users to list additional contact info for other devices they wish to be able to receive notifications, even allowing them to disable the alarms, considering, of course, permission is granted by the initial user. Overall, with the time that was given, all the primary goals were achieved, and all the additional features I just went over are not essential to the functionality of the system, but would only enhance the user experience and make PorchGuard a competitive product in the market of smart home IoT security systems. Thank you for your attention, and may the pirates change course for different seas now that PorchGuard stands vigilant.